Hello everyone, welcome to the first video of our playlist. In this video we are going to see about how data is actually stored in our databases. For that we need to understand first how actually hard disk work. So let's understand that first. For understanding the hard disk we need to understand its three components that are known as tracks, blocks and sectors. So these concentric circles that you are seeing are known as tracks. So let's say this is track 1, this is track 2, this is track 3 and this is track 4. I think this is pretty simple. After that, these tracks are divided with the help of these vertical lines, and when these lines are going to divide those tracks, they are going to form a pie shaped structure. This pie shaped structure is completely known as a sector. When these concentric circles are going to be divided with the help of these vertical lines, they are going to form this particular block. So let's say if we want to store a movie in our hard disk, so what will happen? It is going to be stored in multiple blocks. Now let's say that this block size is going to be of 100 bytes. I'm just assuming for the video reference that it is of 100 bytes. Usually it is of 8 KB or 4 KBs depending upon the OS and the hard disk. Now let's understand about the block addresses. So I mentioned you that this is track 1, this is track 2, this is track 3 and this is track 4. And let's say that this is our sector 1. Now what will happen in that case, if you need to find out the block address for this particular thing, then we will say it is going to be 2, 1. 1 is going to denoting a sector and the first point is going to be denoting a track. So let's say if I need to reach on our 2, 1 block, it means that I need to go on the second track and in the first sector. Let's say if I want to go here, okay, so this is our first track and this is our second sector, so its coordinate is going to be 1, 2, first track and second sector. I think this is pretty clear. Now we know very well what is a block address, track and sector. Now let's understand how physically we reach to this particular block address. So this is our disk that is connected to a pole. This particular disk is rotating and after that there is a pin pointer on the top. This pointer is going to be on a particular track. Let's say it is on the track 3. And if I need to go on to the track 2, it will move forward. If I need to go on the track 3 back, it will go back. This is how this pointer is going to move and our disk is going to be move into a rotational motion. Now let's say I want to go on block address 2, 2. What will happen in that case? So our pin pointer is on 3, it will move to first of all 2.2, and when the disk will rotate, it will figure it out when the 2 sector will come and it will reach the exact block. This is how we will reach to the exact block address. I hope you understand the concept of the hard disk. Now let's connect this particular point with our databases. So I made one student table. In this table it contains 3 columns: ID, name and age, and ID is going to be 1, Andrew and 10. This is going to be our rows. We need to store these 4 rows. So let's understand how much data a particular row is going to contain. So let's say our ID is going to take 4 bytes, name is going to take 20 bytes, age is going to take 4 bytes. So I'm just assuming that extra it is going to take 4 bytes. So the total sum is going to be approximately 32 bytes. We also make one more assumption that our block size is going to be of 100 byte, but in general it is going to be around 8 KBs. Now what happened? Now we know that each row is going to take 32 bytes and our complete block size is going to be of 100 bytes. So how many rows can we insert into a single block? We are going to divide 100 by 32 and it will give us approximately 3.2. So what we are going to store? We are just going to store only 3 data into a single block. That is going to be 3.2 and let's say 3. It means that we can only store 3 rows into a single block. I think this point is clear. I also want to mention one more thing that I missed actually. So this is a complete block and let's say I need to go on to a second row. Okay, so let's say this particular block contain 3 blocks. 1, this is the 2 and this is 3. And need to go onto the second row of this block. Now we very well know that our track is going to move, this pointer is going to move, our disk is going to rotate. Now we know very well that we can reach to a block. But how will I reach to this particular row? For that, in our block, when we reach to this particular block, it will start reading it. And when it will start reading it, for the every section, this particular area is going to maintain one offset. That I am consuming only that much 32 bytes. So this particular coordinate is going to be something like that. It is going to be, let's say 4, 4. 4 is going to be our track. 4 is going to be our offset, and after that this is going to be 32. It is saying that I am consuming the first 32 bytes. After that, the next pointer will start and it will go to 64. So it will say I am just consuming from 32 to 64 bytes. After that, the third one will say that it is going to be 64 to 96 or something like that. This is how we are going to reach to the actual row. Now we understand this particular thing. We understand that 3 data are going to be stored into a block, how we'll reach to the exact row with the help of the disk, and we also understand the concept of the offset. Now what we have figured it out till now, that 3 rows are there for one block. It means that 3 rows can be stored in one block. So these 3 rows are going to be stored in one block, and this binode, the 4th row, is going to be stored in the another block. And let's say we insert more data, it is going to be stored in 5th block, then 6th block, then 7th block, then 8th, then 9th, and so on. Okay, the data is going to be stored. Now we know very well that 3 rows are going to take one block. So let's say that our data will be increasing. Now for the 30 rows it will going to take 10 blocks. For 300 rows it will going to take 300 blocks. For 3000 rows it will going to take 1000 blocks. For 30,000 rows it's going to be take 10,000 blocks. I think it's a very normal scenario that we see in the production, that let's say there are going to be 30,000 rows in a single table. I don't think so it's a very huge data. But now what will happen? We are going to use a hard disk. We want to search the data into that particular hard disk. It means that we have to go through each block, and now we have to figure it out that particular row will exist or not. So let's say if there are 30,000 rows, we have to go through 10,000 blocks, and it will take so much time, okay, every single time. So it will take O(n) of searching time, okay, because we are going through every single block, and this is going to slow down the speed of our database. This is the whole problem. Now in the next video, we are going to study about the indexing and how we can optimize this. So thank you for watching me, and let's meet in our next video where we will study about indexing.